In this course, we're going to use a set of Jupyter notebooks that will allow us to run the code, see how it's working, examine the output, and so on. You can use this GitHub repository with all the notebooks. There are also some explanations, some diagrams that you can explore, explanation of the different problems we're going to solve, and a quick setup so you can either follow the notebook here by just clicking them and see this kind of a static view of it, or you can go and install it locally. There are two options to run all the dependencies. One is with additional pip. All the code is in Python, or you can use UV. It's much faster using Rust. And Rust is a growing language now alongside Python. Quadrant that we are going to use is written in Rust and so on. So the vector database enjoy the performance of Rust. So feel free to follow the notebooks either in the GitHub website or run it locally. So here I'm going to use my Visual Studio Code environment powered by Cursor, and we're going to run the code here. So this is the simple RAG implementation, the first notebook in our journey. We're going to see what is the happy path of using RAG. We're going to load a small database. We're going to encode some of the columns, and then we will apply the retrieval, the augmentation, and generation to see the outputs. To make it a bit clearer, I'm using the rich Python library to make the output stands out and be easier to understand and read, using console with a custom theme that works well in dark mode. First, as we mentioned, we're going to take a simple data, a few thousands of rated wines in a CSV file, and we're going to turn it into records so we can then use it to load the data. Here are some examples of the data. We have a name, we have the region, a variety, rating, notes, and so on, a few thousands of those. As you remember, the first step in the indexing, the zero step, is to encode the documents and to put them in the vector database. So here is our quadrant database. We're going to run it in memory. There are other options to run it on disk or remotely in the cloud and so on. Here, for the simple example, we'll use memory. And the embedding. The embedding, we will use the library from Hugging Face, the sentence transformer. We're going to dive much deeper into it in the second notebook. But for now, we're going to load one of the popular models and use it as is. We're going to create a collection. We're going to call it top wines. We're going to give it a name. The parameters of the vectors are the size is the size of the embedding model. So the encoder here is the one defining how wide is each one of our vector, how many dimensions, and we're going to talk a lot about dimensions in the second notebook. And we're going to use a distance function, or what is the proximity between the vectors using the cosine. Once we have this definition, we can upload all the vectors into the database. So we're going to go over each one of the records in our data set, and we're going to encode the notes. If you remember, the notes is the long textual part of each one of the records, and we're going to use that for our encoding and for our semantic search. Once we finish this upload, it can take about a minute. It depends on the speed of your machine. We're going to see that we have the collection. It's green, it's ready for us to use. We see that we have about 1,300 vectors, records, documents that were uploaded. We see the vector parameters, so the dimension is 384 as is defined by the encoder. And we're going to ignore now the other parameters, but for now we are ready to do the retrieval. So here is our user prompt. Suggest an amazing Malbec wine from Argentina. So the first step we need to do, we can take this text and we need to encode it. And now we have a vector. This vector can be matched and searched to the index that we just created here. And we can just ask the Quadrat client, please search in this collection, this vector, please give me the top 3 documents that you found. Here is some code to make it a bit easier to us to see the records. So here are the records, the name, the region, variety, rating, notes. Again, it's a longer text, so we trim it to show it in this diagram, and the score of the match. That is how much the vector of the query is similar to the vector of the record or the notes. So these are the top 3 that we found. So this was the retrieval part. The augmentation is quite simple. We're going to take the documents and put them as part of the prompt. But before we do that, let's try to take the generative model, the LLM from OpenAI, and ask it the same query of the question without our retrieval code. So now it's the same prompt. You are a chatbot, a wine specialist. Your priority is to help guide users in selecting amazing wines and so on. Quite simple. Please recommend me a good wine based on the query of the user. The same Malbec from Argentina. We're going to call the LLM, and we get a reply. The reply looks okay. Again, the local Malbec from this valley in Argentina is a good selection. But maybe I don't have it in my inventory. Probably there are new wines since the model was trained and so on. So we want to get better results that match our business requirement using the retrieval result. So what we're going to do is we're going to create a search results as a list, and we're going to add it as the content to the query. So it's the same prompt. You are a wine specialist, or priority to find selecting amazing wines, the user prompt, and the search result, the retrieval results. And we can call it. And when we see now, we're going to see that the recommendation is on the Cantena Zapata Argentino vineyard, which is, if you remember from our table, is the most likely match from our inventory, from our menu. And the recommendation is also good, but also matching the needs of our business. So as you can see, the simple RAG flow of indexing the documents, of doing the search, and augmenting the prompt with the results and asking the LLM to generate the response gives us a good response that is also aligned with the internal data that we have. So this is the Happy Path, very quick example of building a RAG application. And now we'll start diving into the different aspects and see why RAG in demo is one thing, and when we try to use it into a more real life scenarios and productions, it start to work not as good as we wanted, and we need to advance our concept and build something a bit more elaborated.